Yesterday sucked. His crash into the wall totally took me by surprise. I know I rushed the autonomous test with the implementation of his side sensors, but I really didn't expect it to go as badly as it did. In any case, I've been working through kind of what I thought were the causes of that and came across the kind of the usual suspects and stuff that I didn't really think were going to be a problem. And I've made progress. If you were hoping to see ROVer retry his autonomous drive test, join us tomorrow. If you want to see some debugging and kind of me working through exactly what went wrong and how I'm going to fix it, let's take a look.
One of the first issues that I kind of stumbled across, and again, I stumbled across because I was hunting for one thing and found another. But let me show you.
Forward obstacle.
So what you're seeing here is ROVer's executing the hallway program. He drove forward, encountered an obstacle, reversed. He's now rotating his wheels in the direction away from the obstacle that he encountered. Once he finishes rotating the wheels around, he's on his third. He's about to do his fourth wheel, his fourth leg, so to speak. Then he's going to do a short drive forward, which will start now. So he's done that, and now he's going to straighten out the wheels, as you can see, starting with the front right, followed by the front left, and all the way around. You saw him drive forward, drive backwards, drive forward again. And one of the issues had to do with what you see here in the command center, this deceleration of change of direction. It has to do with the RoboClaws, the motor controllers. When a particular command is sent to the RoboClaws, they execute that command until they either complete that command or get a command to decelerate. And by decelerate, it's basically a change in direction. And that can be confusing because a change in direction may be a deceleration, or it may actually be a change in direction, meaning we were going forward and now we want to go backwards. ROVer's just running through his commands. When we actually want to change in direction and not just decelerate, we actually have to precede our change in direction command with the deceleration command, and that's what you see here in the command center. So yesterday I issued an all stop command, kind of all zeros for speed, acceleration, and distance, and then we saw him shoot forward at a rapid speed into the wall, which took me by surprise, of course. But the cause of that was the buffering. So we hadn't actually cleared the buffer, and when I issued that all stop command, he then resumed what was in his buffer, which was the previous drive forward command, and that's what caused that to occur. As you can appreciate, a contributing factor was the fact that we had a left sensor go off, but that wasn't actually the cause of why he shot forward.
So the buffering in the motor controllers, that was one issue. The second issue that I've come across, and I don't yet have a particular solution for it, is anomalies within the sensors, specifically the ultrasonic sensors. They are a little bit unreliable, which no sensor is perfect, but these guys, they tend to trigger ROVer's programming all too often. So I need to put in some kind of checks and balances to make sure that when they do trigger, we kind of have some sort of confirmation that it's a real trigger and not a false positive. I have a few ideas about how to go about it.
So what you're looking at here are two outputs. Over on the left-hand side, we have kind of where I want to draw your attention first. And these are serial outputs from the Arduino Uno as ROVer's forward sensors are running. SFL stands for sensor front left, and SFR stands for sensor front right. Those are our two ultrasonic sensors. And as you can see, within a few seconds of each other, they each report two instances of zero values for no apparent reason. The values before and after those zeros are more normal, and there's no gradual kind of progression to that zero. They're just anomalies. But if they happen at an instant where ROVer is performing a drive command or something like that, where he needs those values, they can trigger other actions, other commands within ROVer's programming, which of course would then disrupt what we actually want him to do. By contrast, if we look over at the right-hand side, we see what an actual trigger event should look like. So SFC is our sensor front center, and it basically is showing that a value of between 23 and 18 very consistently, and anything below 40 indicates a trigger event in the case of ROVer's programming as is currently set up. So we can see that when it's a real event, it's very consistent. When it's an anomaly, it really has only kind of a couple of instances where it throws a weird number, a weird value, which we can basically add some programming to exclude kind of those one-offs or two-offs or thereabouts. Unfortunately, of course, as is usually the case, it's not even that simple, because once in a while he throws anomalies that aren't zero. If it were just zero, we could consistently just ignore zeros, because these ultrasonic sensors are always going to trigger we're always going to have trigger values for ultrasonic sensors that are above zero, so we could ignore zeros theoretically. Unfortunately, you can see here that today's testing, where we got a case of a forward sensor right, this is an ultrasonic sensor, getting a value of 6, and that actually happened in a moment where it shouldn't have happened. So I was very curious as to why that occurred. And we can see here the output from the Arduino on the left, and you can see that the SFR, the sensor front right, that's the one that got triggered with this value of 6 here. Right before that value of 6, it was 59, and then right after that value of 6, it was 60. So that 6 is basically, it doesn't mean anything, because we saw a second ago that when it's a real event, of course, it doesn't happen in a flash of a second. It's that obstacle that's blocking the sensor is there for at least a few seconds, and this is reading many times per second. So a one-off like this we can ignore, but I got to figure out exactly how to do the code in such a way that we don't end up ignoring a real trigger event.
So as you can see, between the RoboClaw motor controller buffers and the sensor anomalies, we had a few things kind of working against us in yesterday's test. I think I've got solutions for how to work those through. The buffers, I've already implemented a solution, tested it, seems to be working reliably. For the sensor anomalies, I'll have to play around with a few different options. I don't want to use the outliers script that we did before, because it's a little bit kind of brute force for something like the sensors that we use so regularly. And then once we've got that, we'll give the ROVer another try at the hallway and see how it goes. Yeah, it's the nature of robotics. It's kind of troubleshooting, debugging over and over again. I learned something at every step, so yeah, it sucks when things don't go right, but ROVer is going to be all the better for it as a result of yesterday's test. So it's all good. So yeah, hopefully next episode tomorrow, hopefully, will be ROVer's next attempt at the hallway. Join us then. Subscribe to get notified. Use the comments down below on YouTube or over on ROVer's site. We'd love to hear from you. Give us a thumbs up, and we'll see you guys next time. Cheers.